This time on Captain Cash's Laboratory, we're going to be working on Esmerelda's, what do they call it? Shoe shop from Department 56, if the shoe fits on the roof there. So the problem with this one is the lights don't work. This is a 3-volt unit that uses the 5mm barrel. It is very easy on the style Department 56s to plug in a higher power and then blow the internals. So I have it hooked up to my machine at 3 volts. If you notice, nothing is lit. So it doesn't work. That's why it's here. So we're going to see if we can make it work. So I'm not sure what color the lights are supposed to be. I can easily look it up online. It looks like amber, according to the picture on the box. So the problem with this one is, besides the lights, getting into it. This is a glazed bottom piece. And the problem with glazed ceramic, it cracks really easy. And that's a bad side effect of glazed. So you can see how this is all rough and this is all shiny. It's glazed. I'm going to have a video coming up probably in December. I'm sure this video won't be up until sometime in December. Right now it's still November. And the problem with the glazed pieces is they don't like to get reheated and they crack. And that's a bad thing. So I just poked to see if I could get the seam to move it all on this plate, and it just started chipping, which is the problem when they use the glazed stuff and then they glue in the non-glazed stuff. So it's a bad thing. Not all their pieces are glazed. The majority of the ones I work on this channel are standard, just kilned. But the glazed ones, for some reason, they just they have a tendency of breaking. And I mentioned that on the Flamingo Motel repair, that the glazing is notorious for cracking once heated up. And I have one I started working on that as I heated it up, it cracked. So I'm not done with it or haven't finished opening it, so the video's not done yet. But I just want to let you know in advance. So I'm going to turn on my heat gun at a very low temperature, as low as it can go, which is still hot. It's 100 degrees Celsius or 212 degrees Fahrenheit. And I am going to apply a little heat to the non-glazed glued in piece. The person that owns this said it's okay to break this piece out if I have to. I'm going to try not to at first, but if it won't separate, it's going to have to be broken out. You can replace it with just a piece of plastic. Just cut it into a rectangle, you're good to go. It won't be original, but it also means you can open it back up if you need to repair it in the future if need be. I'm hoping because the edges are not glazed, it won't have the same expansion issue. Always keep your heat moving. Point at one spot, you'll create an extreme hot spot. The expansion of material will cause fracturing. This is one of the reasons I'm not a big fan of porcelain. I know a lot of folks out there like it. I'm not a big fan of it because it is extremely fragile and it is sensitive to temperatures. More sensitive than plastic and resin. Yeah, it's just starting to flake. Yeah. So this is the problem like I was talking about. I'd rather have this rectangle of ceramic break than the entire house, but I'm going to continue to heat it up. So I'm heating up the entire surface so we kind of get more of an even expansion, focusing on the seam so the glue underneath will start to feel the heat, and then going across the whole plate so it can expand evenly and hopefully not chip anymore. But if it does, I can get some white plastic and put a square in here. I might have some white plastic. If not, I can 3D print a white plastic plate. I don't think it's gonna work. I think she's just gonna come out in pieces. I'm barely putting any pressure on this and it's just cracking. Maybe on this side? Nope. Jeez. I don't remember the reason why the lights burned out. She may have mentioned it and I don't remember because I get a lot of emails. I think it was the wrong power adapter. I've had several emails about that. The one thing I don't like about Department 56 is they don't tell you the voltage. They just tell you, oh, it uses adapter 56.12345. That's great. Well, when you discontinue making the adapters, what's the voltage? But this one is 3 volts. The OEM adapter is 3 volts at 500 milliamps or a half an amp. So if you buy it from them, it is on their Department 56 parts page. I did look before I started filming because I needed to verify the voltage. I figured it was 3 volts, but I wanted to verify the voltage. And then you can buy it from them, or you can probably buy a generic on Amazon, but make sure the polarity is correct as well as the voltage. I've had a few where the voltage is incorrect. It says it's this voltage, but it's not. So just be wary. I like to check my meter, my power supplies with a meter when I buy the aftermarket ones before I plug them in. I've just seen so many aftermarket ones put out too much power, and that's bad. Something like this, if it's just what I think it is, a resistor, the resistor may have melted and everything else is fine. I don't know until I open it or get into it. That's what I'm working on now. But any number of things can fail. It could be a bad wire. It could be a bad, all the LEDs are burned out. I don't think there's a circuit board in this. So I said I think it's just a resistor. Because a lot of these LED houses from Department 56 are just resistors. They're not anything spectacular. They don't need to be. A resistor will do just fine. I'm going to not even bother with the heat anymore. I think the heat is actually softening up some of the material. So if I can just chip out the edges, maybe I can get the rest of this out. I wouldn't recommend a grinder. They do make grinders that'll cut through porcelain, because the vibration could shatter the whole house, and that would be really bad. A cutter with a diamond wheel, I think you'd have the same problem. I think the vibration would cause the whole house to shatter. I really wish they would have made this disc something other than ceramic, or this plate. I don't know why they chose ceramic. It seems like it'd be more of a hassle. Make the whole house out of ceramic and then make the plate out of plastic. That seems like it would be, in my mind, a smarter idea. Also should be cheaper. No, we just need a whole bunch of plastic rectangles. Okay. Not much bigger than a AA battery box cover. This is definitely going to take a while. So I'm probably going to end up pausing this just to save on time. I'm literally going to go around and slowly chisel away at where the glue seam is, and then clean up the mess. So yeah, I'm going to go ahead and pause it for a couple of minutes. I'll let you know approximately how long it takes to actually gain access through this panel. So I shall return. Okay, it only took another 5 minutes, believe it or not, and bottom's off. A couple of it came right off in big chunks once I chiseled the edges away. But deep inside, I don't know if you'll be able to see. Let's see if we can see with a flashlight. You see that? That black? It's off the side of the white. That's a burnt resistor. So, it looks like the resistor burned, which usually indicates the wrong power supply. So, now we need to pry it out. Well, the reason I say pry it out is because it's lots of hot glue in here. I haven't actually done any of that. I said I would just come back after I got the bottom off. I'm going to need a little additional light in here. Might be able to shine it through the doorway. That way I can see. That way I don't tear any of these little wires. Yeah, that is definitely smoked. It looks like maybe 2 resistors in here. It's hard to see. There we go. Alright, so some of the wires are broke off, and that's because of the melted components. And it doesn't stick out much further than the bottom. Yeah, you can really see that burn right there. So, I'm hoping the lights still work, and it's just a burnt component. They don't give you any play. Yeah, this light that goes up here is glued right up here, and there's like no play on the wire. So that's horrible. Let's oh, there's a stack of resistors. 1, 2, there's at least 2, maybe 3 in this bundle. are all cooked. That indicates to me that they're different color lights. So if they're usually the same color, I'll usually just use one color or one resistor because they all have the same voltage. But when you have multiple resistors, you usually have multiple colors because they have multiple voltages. Unless they're all the same color and then each resistor was for each light, which really isn't efficient. Trying to get the heat shrink off so I can see what's underneath it. I'm sure it's just wire, but I still need it off. There we go. A lot of burnt plastic. So there is 2 resistors, nothing's in there, and 1 direct power, meaning that one of the lights is directly connected to the incoming power. I'm assuming that would be a white light. And yeah, I have 3, looks like there's a total of 3 lights in here. So 2 are resisted and 1 is not. And these resistors are blackened. These little black specks, if it shows on the camera, which it probably won't because of the light, these little black specks is the resistors just disintegrating. They got hot. Now we need to see if the lights actually work. So my problem is I have 2 resistors and 1 wire. And you can't see it because of the angle. So there's 2 resistors and you can see the end of the wire right there. So I gotta find the other wire that burned off. So there is a light circuit board right inside, right about here in the shoe, which I'm assuming is the main light. Yeah, that's the one that's hot wired. So where's the other wires? Where's the other broken wire? The one that burned off. So I'm gonna get rid of this one because I can't maneuver it as good as a flashlight. There it is. Wow, it's way inside. That's going to be a problem. So it burned, and the wire is right about here. So that wire is not to be extended. Problem is, how am I going to get this? If I could get the sheathing off, I could extend it. So I found the secondary wire. See if I can strip some sheathing off. So, like what those doctors do with the robots when they do everything orthoscopically. This is not fun. Well, let's hope that the wire's integrity is strong enough to let me pull the insulation off without breaking the wire up inside the house. It's just a piece of glue that's hanging and I keep catching it. So I just remove that with the plier or the cutters. Alright, I'm not good at left-handed stuff, but I don't really have a choice. Just tucked over here. A little pressure to start cutting the insulation. Let's see if I can get So I'm doing with the tweezers, needle nose pliers, is grabbing the wire and pushing it in as I'm using the cutters to pull it out to try and strip the insulation. The porcelain is semi-translucent, so I can kind of see through the house, but it's not as bright as I'd like it to be. Alright, screw it. We'll do it by feel. First things, let me grab the wire, and now I'll grab the wire, and I'm going to push and pull. Nope, I slipped off, which is a much better option than breaking. Alright, grab the wire. I got some insulation. I don't know if I got enough. It actually might be enough. Yeah, it's just a melted mess of burnt stuff in there. So there's still a puddle of glue in there. When I got it out, it just pulled it out of the puddle of hot glue. I didn't get it to break free from the porcelain. And you can, there's just all sorts of melted. The wires that are broke are all sticking up and melted. This thing got hot real fast. Let's see if I can trim a little bit more off. It's one of those where I should stop when I'm ahead. I'm kind of getting concerned. But if I don't have enough, I won't be able to do this. And if I have to, that's better. Yeah. So now I have about 1/8 of an inch of bare copper wire sticking out of the wire that's right about here inside the shoe. That will give me a chance to solder on an extension wire to bring it down to where I can try and repair this house. I do want to see if it works. So what's concerning me is the main LED is probably burned out because there's no resistor on it. So I'm putting out 3 volts and I got 0 resistance, which means the light's burned out. So I'm going to turn this down. I'm going to drop it to 2.2 volts, which sounds like an odd number. Most LEDs, so it's bouncing between 2.1 and 2.2. I know you can't see the machine. The screen points this way anyway, so even if the machine was sitting here, you still wouldn't see it. So it's 2.1, 2.2. It's bouncing back and forth because it's about halfway between. I want to test the lights that are farther up and pray that they're not burned out, because I think the resistors did their job and acted like a fuse. But I need to strip this wire. That just broke, didn't strip. Let's try it again. That time it stripped. So the outer collar is negative and the inner pin would be positive. So I don't know what's supposed to light up, but I have no resistance, no amperage. But I just clamped it here. Let's see. Actually, I might have that backwards. Trying to reach the one on the inside to see if I can get that one to light. See nothing illuminating anywhere. You know, I wish they would show what these look like when the lights are on. I'm going to quickly look it up real fast because I need to see where the other wire goes. I know one wire's here and one wire's here, but where's the other light? Is it behind this door? You can't see because of the shape of the house. So we'll quickly look it up. Esmerelda. Shoe shop. There we go. I see that our light, saw it in this picture, and I see it in the house. So I see where the pictures are. So I know that lit up. The other light's right here. I can see it sticking out of the porcelain. And then the other one's right here in the bottom, which lights up this window. And I guess it lights up this too, because it's a brighter light because of its size. And this looks orange in the picture, and that's yellow, and that's yellow. At least the way the picture's portraying it. That could be white. Sometimes the pictures aren't the greatest. Let's see. There's a video from Spooky Villages, and I know he, Doug, likes to show these in the low light. There we go. I just skipped past it. All right. Pause. So, it's kind of hard to tell, but it actually, the camera doesn't even hardly show on the picture. So this looks like an orange or red light. That's definitely a yellow light. And then the light that shines through here and through the hole in the foot kind of has a yellowish tinge too. But yeah, it definitely all has a yellow tinge. And the house isn't painted on the inside. So I know it's not that. And that really looks red. And that would explain why we have different resistors. And that's because we have different lights, which is what I was thinking. So the resistors probably didn't work fast enough, and because the red light should come on at 2 volts, 1.8 to 2.2. Yellow lights usually come on around 2.2. So I just bumped it up to 2.2. I'm shielding this so I can see it because the lights above me are too bright. I can't see if this is flickering or not. Doesn't appear to be. Now we're going to have a hard time this one might be okay to replace. That one there is going to be a pain. And this one in here, I'm not sure. It might be easy, it might be hard. Trying to lift the glue so I can get this one out. So I'm just working the screwdriver under the big ball of, I want to say snot, because it sure looks like it, but it's just the glue. Trying to carefully pry. I don't know how they got this in there. They must have just stuck it in with their finger. How big is that glue? That is a lot of glue. Wow. It's impressive. I might have to, I don't want to because it's so fragile, throw some heat in here and hope the glue will soften up just enough I can get the light out of it. It's definitely softer. My screwdriver sticking to it. Getting some movement. We got some of the glue to break free. Almost looks like it's an LED on a cob. It's hard to tell. It could be an incandescent too. A little 3-volt incandescent. I think I still have some of those. There's a lot of glue in here. And they used a lot of glue. I've seen amounts of it. Oh, yeah, I can see this is a big LED. I can see it through this hole right here. And it's blown. It's burnt. So all the LEDs took a hit when the voltage, whatever happened, over voltage spike. I don't know if we'll be able to get this board out. There is so much glue. So if you have this piece and you look through the hole in the foot of the shoe, in the toe area, you can actually see the light inside. And if you do it, you'll see that the light is, one, it's a 10 millimeter LED, and two, it has, at least this one, has some obnoxious amount of glue holding it in. I'm actually starting to chip the circuit board it's attached to, just trying to get it to break free. Ooh, I think I got it. Also, using this hole in the toe helps a lot. Got it. There it is. Yeah, the circuit board did kind of break a little bit. The wire is still stuck in the glue. Yeah, broke out now. Alright, let's turn off this. Yeah, that thing got real hot real fast. And this does have a resistor. It's attached to the board. It's a 470 ohm resistor. It didn't stand a chance to whatever happened to this. But take the wire off. Alright, let's turn this off. So this is going to be a difficult one because it's all porcelain, there's no access, and everything is burnt. The resistors did fail, but unfortunately the lights failed with them because the power was more than it could handle. I'm going to zoom in so you can see this. Give me a second to focus. So, heating it up and prying, that's me, the damage here. See that big spot right there? That's a burnt LED. So this is a very large LED. This is a 10 mil, I believe is what they're called, 8 or 10. And I do have some of this size, but they're red. They're not white or yellow. It's hard to tell. It looks like the LED was supposed to be yellow. And this board, I'm going to zoom out again since I picked it up. There we go. And this board has no markings. All it says is the part number on the back. It says HK LED 1011. And it has a little surface mount resistor right there. Right here. Which I'm sure that guy is cooked. Even the solder joint got hot right here. And that's the solder joint that the resistor goes through. So if this solder joint got hot and turned black, that resistor's gone too. You don't have to use a surface mount resistor to replace it. You can just use a regular resistor. And you don't need to use a circuit board. I think the reason they used it is this was usable for other things. It's got extra holes in it for extra LEDs or components. So it's probably just a generic board. So It's not a problem. Put a new light in it. And if you can't find or buy just one big LED, you can take a cluster of like 3 smaller ones for the same amount of light. I've done it before. I don't remember which piece, it was a long time ago. But the big LED, we changed it to a cluster LEDs, which actually helped with the light distribution and made the dome look better. I think it was on one of the cluster lights in one of the science labs. So this, we have wire that we can pull through the little eyelid to give us slack to replace this. And we're going to have to find the seam to separate the unit to get inside. So that one I'm not overly concerned with. Worst case is we just put a slice with a razor knife, which there should be a seam, and we can open it like a clamshell. The one that's going to be the hard one is that one right there. That guy right there. And I'm going to take a closer look at it. I'm sure it's blown, but I want to see if it has the same blown up centerpiece like that one. Yep. Not only is it blown the center, it actually cracked the resin housing. So that's awesome. And let's take a closer look at this. So using the magnifying glass as I wear, so I can see the smaller stuff clearer. The top of this is not smooth, which indicates to me that the top's a big hole, and they stuck the light in there with some glue and hit it with some black paint. So probably just use a razor knife, cut out the lumps, pull this off, replace the LED, put it back on. I'm going to go on a computer and versus a phone and get a better picture of this. And actually listen to the video from Doug. I didn't want to play it because of the copyright infringement stuff. I'm sure Doug would be fine with it, but YouTube wouldn't be. And without him giving express permission to YouTube, I could get hit with a copyright strike. They're really cracking down on that. That's why I was mentioning in other videos, if it plays sound, I will usually listen to the sound and verify it before I play it on the channel, because even some of the Christmas music is now being copyrighted. So it's going to get a little harder when I'm dealing with sound issues to help you than in the past. This one's just lights, so no worries. But the video I was looking at from Doug regarding this probably had sound. So anyway, I'm going to see what I can do as far as getting the light colors, so I can make sure I have the light colors. And if I have the light colors, we'll get them swapped out. So, and then I'm going to study this one more and see what I can do. It's loose. I can wiggle it. Oh no, I can't wiggle it. I'm wiggling the broken plastic where it shattered from the explosion. This must have been a very interesting pop, because it takes a lot to crack the resin on an LED. I mean, a lot. I have put a 2-volt LED on a 12 and a 15-volt power supply. All it did was glow really bright and then get really dim and start to smoke, and that was it. It didn't blow or burn a hole through the plastic. This one's actually shattered. That's pretty good. That's amazing. Because I'm wondering if this can be pulled down, soldered, and pushed back in with a little glue. So I'll see what I can figure out. So I'm going to go ahead and pause it while I do some research on the colors of the LEDs before we put this back together. And if I reuse this circuit board, I am going to bypass that resistor, which is probably blown. And the reason being is that I'd rather have the cluster resistors on the bottom near this broken door that is accessible than trying to pull this back out if there's another failure. So hopefully there's not. So I shall return. I'm going to clean up this mess too. Oh, and one other thing before I pause it, because when I clean this mess up, this is going to go in the trash. So here's the inside, and here's the glue. Kind of see that ridge. This glue was hot because this is where the resistors were, and it changed colors. but they actually have an arrow. I don't know if you can. Whitewashing. They have a directional arrow on how to put this on. Pencil. You can see the arrow now. So this arrow is pointing right up to this. So right there. So this was set to be put on one way, and it's probably because of this groove for the wires. So if you get yours off somehow, and it doesn't chip into 1,000 pieces or break into bigger chunks like this, it has an arrow, and the arrow points forward. Just as an FYI, like I said, all this is going to go in the trash. I'm going to sweep it off, and when I come back, it's going to be clean again. So, all right, I shall return momentarily. Okay, so I went through all my LEDs, and I also looked online. So the light that's right here, which is right here, I pulled it out. It's glued in. Wiggle it out. Use a little heat because they use resin glue to wiggle it out of the porcelain, and then you can pull some of the wire out so you can connect a new red LED. And I say red because in all the videos and pictures of this in low light, this appears to be red. This is either a golden white or a really bright yellow. So I'm going to have to use this as its place. This is a really bright golden white or amberish yellow light. But I wanted to show you that these big LEDs is what they use, and you can buy them. You see the size. And in comparison, that's the red LED to replace that one. And this is the white LED to replace the lantern that hangs off the roof. So LEDs do come in massive sizes like that. This one's red, so it's not going to do me any good because, well, it's the wrong color. And just to show you, it goes there, and okay, so I thought I had some, but I have a package of just red big LEDs. So this, if I remember to hook it up the right way, I did. It's flickering because I don't have a good clamp on it. There we go. So, and that's the white that goes in the light, and this is the red that points down here. So the wires, I went ahead and cut them, and this lantern, it's not pressed in. The lantern's actually cast around LED, so unfortunately the top of it cracked off. There's the piece. It can be glued back on and you don't even really notice it. But the LED is still all the way down in there. This big chunk of resin is literally just onto the LED. There's no glue. It's just resined in. So this is just painted resin, which is why the paint job varies from house to house I've seen. That's because these are all hand painted, and that's why they vary, is because that's a resin cap. So I'll deal with that one last as far as getting that out. So I'm going to put those out of the way. So this is my LED tester. If you haven't seen it before, basically I just stick an LED in and it tells me, there you go. I know it's hard to see on camera, but this is a red LED. Sometimes the camera doesn't pick up LEDs in the correct light. So, since I have the red one hanging out of the balcony here, I'm going to start with that one. So I'll move that out of my way. This is a piece of trash. So this has a white stripe on one wire and no stripe on the other. I'm going to go ahead and make the white stripe probably positive. I'm going to see if this LED is still visible enough for me to tell you which direction it was soldered in. They have the white stripe as positive as well. So, good. Let's see if I can just slice off the heat shrink and just desolder the burned out LED and then solder in the new one. Doesn't look like that's going to happen, so I'm just going to trim it. There we go. And trim it. There we go. So this LED is also, like this other one, it is golden brown on the inside, and it's not supposed to be. I did check with the owner of this piece, and she says she's using the right power supply. So I asked her to check the power supply to make sure it's not over voltaging, which does happen when they wear out, or it can happen. Sometimes they just quit working, and sometimes they put a lot more power into your product than it was ever designed for. So this one doesn't want to strip. There we go. They only had one size heat shrink. The one side they had heat shrink was a positive, and I think that's because of the very thin gap the wires fed through, which is really small. So I'm going to do the same, because two pieces of heat shrink side by side are going to cause a tolerance issue. I'm also going to cut these back. So heat shrinks on, and I'm going to pre-tin the strip wire. Pre-tin the LED. That. Just trying to position the house in this position where I can solder with one hand and hold with the other. Be faster than trying to go get the helping hands out and do all that. So, negatives on. And there's the positive. Now I'm going to cut off the excess. And we'll slide the heat shrink up. So I'm going to do the same thing they did. I'm just going to put the resistors in here. But at the moment, I just got to feed this wire back in. So I'm using the needle nose pliers to grab the wires for the light. And so I'm pulling with one hand and pushing with the other. So I'm going to feed it back into its hole. What I'm going to do is I'm going to bend, even though the leads are, I think the leads are probably a hair longer than the original. I'm just going to bend the leads a little so they can go around the curve. There we go. There we go. Now the only problem with this LED is it is taller than the original, so it is going to stick down some. There's not much I can do about it. I mean, I can crack the lens. It's what they call it, where you cut a tip of the lens off, but you don't want to cut too much because then the LED won't work. As you can see, it is taller, but it works. Sometimes there's a trade-off, and that's the problem with LEDs, is I could try and find some straw hat LEDs, but I might be waiting a while to get them. But I can put this in here, and I'm going to hot glue it instead of resin glue it or hard glue it with super glue like the manufacturer did, in case it ever gets the same problem again. It'll be easier to take out. And then I can use a pair of these to crack it. And I'll give you a visual representation with the bigger. So you understand when I say crack an LED. So if you look, that right there is the LED. This rest of this is just clear resin plastic. You can actually cut the top off, or break it off, or cut it off with a crack it. So it's shorter, like this one. This is called a straw hat. This is regular. And the difference is they don't have the big dome. This is more of a pinpoint of light. This spreads it out more. That's the reason they probably use it. Well, two reasons. One, it'll give it a bigger glow. Two, it is a lower profile. But I can make this one a lower profile and cause it to spread out. First thing was get it in the hole, because that's actually really hard. I had to keep adjusting the angle of the wires. You probably saw me a couple times squeeze on it till it could go in and around, because it's only the spacing is only about as thick as this right here, so it's very, very thin spacing. So that one's in. Now we're going to do this. So this I'll probably just stick on the circuit board. The wires will not be connected through the circuit board or to the edge of the circuit board. I'm going to solder the wires to the leads itself. I'm just going to glue this to the circuit board. So move this out of the way. We're going to remove this LED. And what I'm going to do is I'm going to put the resistor in the bundle towards the bottom and not on the board itself. That's great and all, but it just makes things easier. for fixing in the future if necessary. There we go. Okay, so next thing I'm going to do is, these like to have heat dissipation, so I'm going to scrape the back of the board, which has copper, and use that for heat dissipation. I'm going to remove some more of this solder real quick. To do that, I'll use a solder sucker. Now if you use regular LEDs, like this style, you don't need the heat sink, but this style prefers a heat sink. That's why the back of them are metal, so it can dissipate the heat, because LEDs do generate heat. Not a lot, but they can. So now I have a nice shiny copper area that this can sit on to dissipate some of the heat through that old circuit board. And I have it somewhere. I have some thermal paste I can put a little dab on, because this LED will get warmer than this one, and we just want to ensure it has a long lifespan. There we go. Make sure that stays straight up. I'll put it right there. So that is soft thermal compound. So I'm going to stick the LED on that. And then what I'm going to do is I'm going to put some glue, permanent glue, around it. On the plastic edges and not where the metal tabs are that I have to solder to. Normally you would solder this directly to a copper pad or pads for each side. So now this I'm going to let sit while the LED gets adhered. So I just need to set it on something where it stays level and not on my bench so it doesn't stick to the mat. Okay, next, now we're going to deal with this thing, which is unfortunate that it is a cast housing. It's cool and bad all at the same time. So we have some broken LED connections in here. I'm going to see if I can pull them out. What I'm trying to do is spin them and break them out of their plastic resin housing. And I'm not talking about the resin lamp, I'm talking about this resin cap that they put on all LEDs. And from what I can tell, this is a white light, so it can shine through the paint. So when they stuck it in, so either they use resin type glue or they resin this around it, but the whole back edge is resined. Then they use a soft glue that they then painted black to hold the wires from touching each other because there's no heat shrink down inside. So it's probably like a hot glue. So now that that's out, this will slide in, and then I can resolder. Now the difference between the one I pulled out and the one I'm putting in is this has a shoulder, so it kind of stops it part way, but you can wiggle it and get it in more, and then you should be fine. You can also sand off the shoulder or snip it off with a pair of these if you need it deeper inside. This is the same principle as cracking an LED. I'm just going around the edge and then trimming off some of the shoulder just so I can get a little bit better depth and not put any pressure on it when I glue that piece back on and then touch up the paint. Taking the light out of the bottom of the walkway, it does chip the paint. There's really no way around it because of the type of glue they use. So just be careful, and luckily it's pointing down so you won't see it. It's not much. I don't want to say, oh, I took out a whole bunch. No, it's like you scratch the surface around the edge of the light. And that's because they glued it in, and the glue is glued to the paint. So when you start getting the glue to separate, the paint sticks to the glue. So these are not designed to be repaired. Just remember that when you're working on them and you start getting frustrated, it's not that you're doing it wrong or having your new pair doing something that maybe you don't understand. It's that these are not designed to be fixed. They're designed to be thrown away and replaced. So just give yourself a little patience and leeway. There we go. Now it fits a little bit deeper, much nicer. So I'm going to glue on this chip piece first, and I'm going to let it cure before I put that inside. Now, if you've been around for a while on the channel, and I always use Gorilla Glue, I test the different glues, whether it's hot glue, Gorilla Glue, etc. And whatever works best, that I find works best, is what I use. I'm not sponsored by them. They're expensive. I buy them often. So now while I'm holding it, I'm going to use the razor knife X-Acto knife, to kind of trim the edge where the glue is coming in, and also where there's still a piece of resin that was on the broken piece. So that way I can put the new light in without causing it to chip once it cures. Piece of solder. Almost blew my finger. But as you can see with the glue, it's like it never even cracked. Again, I've mentioned it many times. That's why I like plastic and resin pieces, is because they're easier to fix. And if you make a mistake, or you have something like this where you're trying to get the resin out and it ends up cracking because it's resined in, you can fix it. Just switching to a new razor knife because that other one, the blade chipped. It chipped when I was trying to cut the top off of the LED. Look at the cuts of that resin lip so much better now. There we go. Alright, so now I just need that to cure. And once that cures, I can slide that inside. So I'm going to set that off to the side so it can cure. And now it's got a nice sharp tip. I'm going to keep the cap on. And now we're going to glue this light on. So same thing. This has a white striped wire. It's the same wire. And a black wire. So I'm going to, now that I have a sharper pair, I'll probably trim this insulation better. Apparently just kidding. Oh, there we go. So there's one. I do own wire strippers, but these wires are so thin, my wire strippers don't catch the insulation. So if you see me work on stuff, sometimes you'll see them out, and sometimes I'll just use the flush cutters and use that as a wire stripper. Alright, so those are tinned. I'm going to do the same thing with this. I'm going to tin it just like I did the other one. I'm going to tin it where I can cut the leads off. And I do this for a couple of reasons. Sometimes I'll have to cut the lead short before I do this, but if I can, yeah, tastes bad. This dissipates the heat. I don't want the heat in the lens. The metal sticking out will dissipate the heat. And two, if I need to grab it with something, I have something to grab onto that's not the lens, and I don't risk either shooting it out from inside a plier or breaking the lens. Or cracking it, you know, unintentionally. So, but to each their own. Do whatever works best for you. There is no wrong way, as long as it works for you how you're doing your own thing. Don't forget your heat shrink. Now this one had heat shrink on both wires, and that's because it's exposed. Meaning you would see the metal ends because it's hanging on the outside of the house. So you got to solder this quickly, because if you don't, the heat shrink's going to shrink before you have a chance to actually use it as heat shrink. And then you'd have to do it over again. And I think I might have cut it too long. I did about half this length. There we go. Now, if you only put it on one side because you forgot, you can use a black marker and paint the other side black so you don't see it. This heat shrink, you only need one piece technically, but the reason they do two is for aesthetics. There we go. So that's the hot, which is this guy here. So this is what I'm talking about. So with it extended, I can hold it so I can solder it. I'm going to hold it to the other one because that's not the one I'm soldering. There's one. And there's two. Now, cut off the extra. Hey, you know what I forgot to do? Put the heat shrink on the second one. Kind of like I said, if you do that, you just paint it. Come on. But since I didn't turn my soldering iron off, I'm just going to quickly desolder it. Slide my heat shrink on. resolder it. Need a little more solder. There we go. Alright, so now we have them soldered. Now I'm going to slide the heat shrinks down. Just didn't cut it flush enough. I still had a little piece sticking up. Just want to trim it off. There we go. And quickly hit it with some heat. Done. Now we have the lights pretty much done. We just don't have this one because I don't think it's cured yet. Nope. That's the one thing about Gorilla Glue that's different from super glue is it takes a lot longer to solidify. So the mess that you have on the inside isn't as horrible as you think. The only wires you have to deal with pretty much are the hot wires where the resistors are. So I'm going to go ahead and just cut out this mess right here. And this way you can, I'll zoom into those so you can see how cooked they are. And then we just have to strip those 3 wires back. Make sure they're still soldered together, and then solder another bundle of resistors. I'm going to use a bigger resistor because I don't have any of these 8th or 16th watt resistors. I don't buy them because they're specialty. There's plenty of room in here to put a slightly bigger resistor. Now, there is a ground wire or a negative in here, which is to that circuit board for the other LED, but the other ones are all tied together. So anyhow, let me find some resistors. I'll get you the numbers, and let me get this stuff curing. So I'll be back in a few moments. All right, I am back. I had to leave abruptly. It's the next day because this was not curing. I don't know why. It just didn't want to cure, but it's cured now. Anyhow, so the resistors that we need, they're right here. So the red light right here is a 48 ohm resistor. The white light right here is a 12 ohm resistor, and the orange light right here is a 25 ohm resistor. So, like I said, I was going to show you the other resistors. I'm going to zoom in, going down. And then once it focuses, we'll move this into range. There you go. So those are the 2. Because remember, the 3rd one was soldered on that board. So that's the red and the white resistor that are smoked. So yeah, those are blackened. There's no resistance left in them. They are completely cooked. Now these are 8th watt resistors. And these are 1/4 watt resistors, and just to show you, I'm going to set that right there. You can see the size difference. So that bulge in that, those are the resistors. So I don't buy 8th watt resistors. I don't think I ever have. I always just make space for the bigger 1/4 watt or larger, if necessary, resistors. So I'm going to zoom back out. Apparently I do that wrong. There we go. And throw that away. Alright, so I have my soldering iron already on before I started, so that way there's no delay in waiting for it to heat up. So I'm going to first start with soldering the resistor to this. So what I did is, because you can't tell which is positive and which is negative, I put a black line on the bottom to tell me this is the negative side. I'm going to solder the resistor to the positive side. Doesn't matter which side you solder it to. That's just how they had it in here. And then this was the negative wire that came off of it. Now, you could, if you were concerned, put heat shrink on this and protect the leads, but I'm not going to, just because the hot glue will do it for me. Sorry, I have to pause it again. I got another phone call. Okay, sorry about that. I'm back. So, I removed the wire from this because the wire, while I was on the phone, I realized that wire is the piece to extend the piece that broke inside, and the ground wire is actually right here that goes there. And I'll solder that on last so that way it's not in the way, because if you remember, the other wire is broke up inside here, and that's what I'm using this for. So I tinned the wire. When I desoldered it, I tinned the other side, so both sides are tinned. And I also tried to get my soldering iron in here to tin the wire that's up inside here, which is going to be so much fun to get to. So, I'm trying to figure out how I'm going to get in there to fix that wire, or to add to it. This is the red LED, and that's the white LED resistor. How are we going to do this? Unfortunately, you won't be able to see anything. I'm going to have a hard time seeing anything, truthfully. This is going to be kind of difficult. That might work there. So, I'm going to try and get this soldered and not melt the other wires near it with the soldering iron, because the whole shaft of this thing is super hot. Nope, didn't work. Retinning it, because apparently some of the solder came off. I'm going to try and retin the wire that's inside here as well. So at this angle, I'm getting enough light through this hole to see the wire. So you've never soldered before, the tip is the soldering part, but this entire shaft, where it's silver and burnt or discolored from heat, is hot. I mean, not hot enough to really melt the solder, but it's hot enough to melt wire. So I am trying to feed this through all those wires without smacking them, and also not resting against the porcelain for too long, because again, this is glazed porcelain. And also try and reach all the way in far enough to solder this in a two-dimensional space, so it's hard to tell the depth. This is one of those things where you just gotta take your time, and if it takes a couple attempts, it takes a couple of attempts. I'm actually wondering if it's easier to solder it through here. And then pull it through with a pair of needle nose pliers. Because now I don't have two hands in the way of my opening. Need to... So the answer to that question is nope. I am getting this wire hot though. It's starting to melt the insulation back. So, because I am touching, but I don't have enough resistance on the wires that when I'm soldering, they're moving away from each other. I think I got it. So the wire is attached. Now I just need a flashlight so I can see if, ooh, that's bright, if I got a good adhesion. And it's not some crappy solder joint. No, she did. Look at that. So, that took a few attempts, 5 or 6, but we got it. Now I can grab the wire with the needle nose, like so, and I can pull it out the bottom. So this wire is the white light on the top. Now, because there is a bare section of wire, I'm going to have to slide some heat shrink in here. I may not be able to, well, I can heat it with a heat gun. So what I'm doing right now is, my leads were long and there's a little piece sticking out, and if I slide heat shrink on, it'll cut the heat shrink. But there we go. So there's my wire, and that's the hot wire. That is the positive. And just, I'll use a piece of red, since I don't have much left, to indicate the positive. No, actually, oh, it's too thin. I need something with a little bit more meat around it, so a bigger diameter. So in my kit here, the colors are different diameters, so I'm probably going to have to use blue. This should get around the solder joint. Solder joint's not a nice, smooth solder joint. It's a little bit of bulbous, just because I can't really get to it. It's still really strong. I mean, I'm pulling on it. It's not going anywhere. And I have a lot of wire touching itself. And apparently that's still too small. Yeah, there we go. All the way in. So the heat gun is set at a low temperature so I don't heat up the porcelain. And I'm just doing this long enough to get the heat shrink to shrink. And being inside the house, there's a big cavity of air before the heat starts getting to the porcelain. There we go. There. So now the wire is extended. Now we'll set this back on its back so it's more secure. So if this is something you're doing, stuff like this, because I had this question real recently, what I used for wires that are stuck inside houses. Needle nose that are long, hemostats, you don't have to get one this big though. Fish hook removers, which is the most common one I use for in-depth grabbing, which I have no idea where that one went, but there it is. Somehow it fell to the bottom. I think that's it. So, fish hook removers. This probably would have worked pretty good too, because it's a little narrower and farther away than those. But it also can reach through the holes because it's so small. So if you do have a house where your access is limited, there are options out there. These were in the beading section of Michael's. So I guess they're needle nose pliers made for beads, bead jewelry. So. Alright, so I know that it's kind of appropriate. The white heat shrink goes to the white light, and this is the white LED resistor. So let's go ahead and get this one soldered on. Now this one I'm going to trim, so I'm going to put the solder pinning much higher up on the metal. Do it right about here. And then I'm going to cut off the end right there. There we go. Nice and soldered. So you're probably thinking, oh, you didn't put heat shrink on it. You're right, because I want to heat shrink the entire LED resistor. Sorry, the resistor for the LED. And I'm going to use clear heat shrink so you can still see the color code inside. Unless it catches fire again, then it'll just be burnt like the ones that were sitting here, and it won't matter. And so that's the white light. And then this one here should be the red light. Let's see, it is. So we're going to do the same thing. I'm going to take the red light resistor, and I'm going to tin it, and we're going to tin this like so. Same thing, I'm going to use the clear so I can see through it. And next, just to make sure everything works, if you watch this enough, you know that I usually test all my stuff. So I'm going to just grab the edge of this, which is the negative, without touching the center pin, which is positive, and that way there's no issues. I'm going to turn on my power supply to just over 3 volts because the other power the one that comes with the house is there's the red, and there's the keep slipping off my finger, and there's the white. And just so you know, the orange works. Good. There you go. So that's at 3.2 volts. I actually set the resistors for a 3.5 volt free float. So now I have it set for 3.5, 3.6. It's bouncing. There we go. So these resistors are set a couple of ohms higher than what's recommended. Kind of a safety thing, just in case the power supply fails. And it goes a little bit higher than it should. Red and white. And the reason I want to do the free float is LEDs don't draw a lot of power, so there's a good chance that you might exceed the 3 volts from your power supply. Not all power supplies are made the same, so some have a 10% free float, and some have a 20%. I've had some that are 100%, which to me those would be defective, but those are usually made for high loads. LEDs are not high loads. This is an all LED house. I did message the person that owns this house and ask if they use the wrong power supply, and the response was no. So I told them to check their power supply, because the way these are burnt, their power supply may have failed, and that would be a main reason for this to turn into smoke. So, all right. So now I've soldered the negative wire to this, the one that was hanging in here. So now we just need to reconnect all the hot wires together, which is the basically they're just the resistor leads, and that's why I'm using the heat shrink that covers everything, so I can cover the leads the entire way. And the reason I didn't cut this one back is so when I shove it up inside, because like I said, it goes in 2 to 3 inches, that gives me my length and I don't have to add wire. All right, so this right here is the hot. This black wire with the white stripe. I need to tin it, so let's tin it. There we go. Now, I'm going to take these 2 LEDs, the LEDs that go to the red and the white, and I'm going to twist the leads together. And I know it seems counterintuitive, but it's not. The power is going through each one independently, because they're all soldered at one junction. So with them twisted together, I can now slide my heat shrink down, which will cover the important end of the LED output, sorry, the resistor output for the LEDs. Keep missing parts of my sentence. And like so. So my Western Union just came undone here. Apparently I didn't twist it tight enough. There we go. Here we go. So the power coming in is now protected for the power coming out with the clear heat shrink, which bonds to the actual resistor as well as to the black wire and prevents any arcing or shorts. So now I'm going to solder my leads to each other, and then I'm going to solder those to the black hot wire. Again, it's a black wire with a white stripe. And the reason I'm giving you the play-by-play is because if I zoom the camera in, I'm probably going to move the house off screen and you wouldn't be able to see, and that would suck. So I'm just telling you what I'm doing so you can see and hear what I'm doing. And then I know on a cell phone you can zoom into the videos. I don't know about your computer. All right, so that's done. Now I'm going to solder on the LED resistor, the orange LED resistor, I should say, like so. So I'm going to solder that one on next. Just re-tin that. And make sure my solder joints are good. I don't want to have any loose connections. Yeah, they're good. And now we'll do a test. So all three lights should technically come on. There you go. White, red, orange. So this is a tedious repair. It's not done yet, but this is a tedious repair. So if you have to do this, you will have to take your time. You will probably get frustrated, and you might have to stop and walk away for a few. Just get that out of the way. And that's not anything to be ashamed of. This is something you learn over time, whether it be the patience part or the technical part. What I'm doing is I'm going to add a little electrical tape at this juncture for a couple of reasons. One, I want to make sure it's also insulated against any potential arcing, but also as a strengthening, and hopefully, if it's a tight enough juncture with the tape, reduces the chance of ingress of moisture, which causes corrosion, which can change your resistance levels. All right, now comes the fun part. Now I got to set this back inside, figure out the position of the light, and then glue the light like right here and shove it in while it's smoking hot with hot glue. We all know what hot glue burns feel like. So where'd my orange light go? Ah. There we go. That's pretty close to where it was. Let's just see how it looks. So the reason I turned my power supply on before hooking it up is I want to make sure that when I move it, it doesn't jar the knob and change the voltage. I've done that once where when I turned it off, I hit the knob and I didn't realize it, and it turned the voltage up before it turned off, which caused it to be higher when I turned it on, and I burnt out what I was working on. Then I had to fix it again, which kind of sucked. So, live and learn. All right, I'm going to turn off some lights so we can get an idea what this looks like, because it's too bright in here to see anything, at least on the camera end. That way you can really get the feel of the new LEDs. Let me turn off my soldering iron. We should be done with that. And one more light right there. Camera is going to adjust. Of course, this is intensely white, and bright because we don't have this on it yet. Once that goes on, it should be good. There you go. You got the nice orange light, the orange glow, the orange glow. You got the red. Now we just have to glue everything in and glue the cap back on. Lights are coming back. One more. There. So, just so you know, with these 3 LEDs, the white, the red, and the orange, and the 3 resistors being 48 ohm for the red, 12 ohm for the white, and 25 ohm for the orange, it is pulling less than 100 milliamps. It's actually pulling 90 milliamps to be exact. It's actually holding pretty steady at 90. It might go up or down a hair as everything warms up. That's also at 3.5 volts. So that is at the maximum power that the Department 56 should be putting out with their free float. So if I drop it down to exactly the 3 volts, which is right here, so the white light's a little dimmer. Well, they're all technically a little dimmer. Now it's pulling 45 milliamps. So it's literally pulling half. So this is what I was talking about earlier when I said, you know, this one turns on at 2.7 volts, and this one turns on at 2.2 volts, and this one turns on at 2.5 volts. And that's why you need resistors. So you can tell when you start running them closer to their maximum voltage or their maximum, technically, amperage rating, how the amperage goes up dramatically. So I lowered it at 0.5 volt and I cut the power consumption by 50%. So the amperage dropped by half with a 1/7 of a voltage range drop. So that's the difference, and that's why you need to do your calculations. You can do the ohm laws calculator online. That's what I use. I mean, I know how to do it. It's just faster to type it in on the computer, and it tells you, or your phone. I also have the little cheat sheets that you have a little wheel and it spins and it tells you what your resistance should be. Normally, I use 10 ohm resistors for the white lights on a 3 volt circuit. I'm out of 10 ohms. I looked it up for the 12 ohm. The difference in intensity is negligible. So this is a 12. But with the plus or minus, it's a 20% resistor. This resistor for the white one actually comes out to 10.3 on the meter. It's not 12 because it's out. It's within the range, but it's just a little lower than the average. But the other ones are pretty close. So the 48 ohm resistor that's in here is reading at 47, and then the orange resistor that's 25 is reading at 26. So they're all within their range. The other two are 10%. This one's the only one that's weird at like 20%. Kind of a strange one, but it's a pack of 5. I think it came in some electronic kit I got a long time ago. But I'll leave a link below for LED kits and resistors, and I'll leave for the different size LEDs, so you can, if you want to get a variety of them. They come in kits of like hundreds to thousands at a time. They're not overly expensive, but they come in big kits. You saw the plastic container I had. I take them out of the kit, which is a bag with Ziploc bags in them, and I pour them into a organizer. It's just easier to work with. So the next part is all gluing. I'm going to glue in the lights, set everything, and then I'll probably just pause it for that. I mean, this video is long enough, and I'm sure you all know how to use a glue gun. Like so. So I'm going to glue the red light in. I'm going to glue the orange light in and see if I can avoid first, second, or third degree burns from it, so I can push it up inside. And then I'm going to glue this in once I get it pushed in all the way. I got a little burr apparently that's still there, but and then we'll come back and do another low light test with the lights set. So the orange light actually set and not bouncing around, and the red light actually pushed all the way in, because right now it's hanging down about 1/4 inch. And then the white light, of course, in its resin painted cap. So bear with me for a moment. I'm going to do this. I'm going to turn this on so it starts heating up. And we're going to get this thing finished up and boxed up and get it back to its owner. Okay, all the gluing's done, and let the camera adjust. So it's not quite focused due to it's trying to focus on the 3 different sets of lights, that one, and that one up here. So the camera's having a hard time figuring out what to focus on. So the only thing I need to do is, now I have it in low light, is the top of the LED I need to paint it black like they did on the original one, so it doesn't shine the white light onto the top of the hat. So doing this, you can see the orange. You see it's coming out of all of its openings, and including right here where it shines onto the feet of the witch. And then the red. So if you saw a few moments ago, the red was more of a beam. I cracked the lens, meaning I made it flat on the top. So now the beam is much wider. And you can see more of the cat as well as the stairs. So it's a much wider beam. I'm going to turn on one of the lights. So let the camera adjust. Now you'll be able to see what I'm talking about. You can see the white shining through the top. So, but you can see it's glowing, which is the point. So I'm going to go ahead and I'm going to grab some black acrylic paint and paint the top of the LED. I am going to find a piece of plastic to cut and glue into the bottom before it goes back to its owner. No, the light's going to come. I'll leave the light off. You know there's a hole in the bottom. Because the 3D printer's down. Don't know why. Every time we work on it, it's having a communication error between the printer and the part that you upload the file to, not the computer, but on the printer, and then the print head. It starts printing and then it stops and says there's a communication error. So until that's figured out, I can't print a bottom. But the easiest way to make it, if you have this piece, if you don't have one, go to Goodwill. Get a jewel case. The old school jewel cases where the top's clear and the bottom is white, black, green, purple, translucent. Find a white one, cut out a rectangle, glue it in. There you go. It's the easiest way, and that's what I'm going to do. I have a stack of jewel cases. Everybody thinks I'm weird, I don't throw them away. But I've used many jewel cases to fix different houses when I have to recreate a plastic insert. So having a half a dozen of them lying around for stuff like this isn't a bad thing. You can even put a piece of foam in there if you want, like the foam that Leamax uses on their bottom, the sticky foam. You can cut a square, stick it in there, and it comes in white too. There's any number of things you can do to fix the hole, or you can just leave the hole. But the reason they don't have the hole is because there's light shining out of the holes. Yeah, there are lights on my fingers. So if it's sitting on the flat, you're fine, but light's going to come out of the back where it's notched for the power cord. So you definitely want to do something. Doesn't have to be dramatic and special and tons of work, just something. Most people don't see the bottoms of the houses anyway, unless they're on a glass top table and you can walk under it or so on. But outside of that, so not too hard of a fix. Now, if you don't have some random orange LED that requires thermal paste, you can just use orange LEDs or orange flat LEDs. I forgot what they're called. And those will work fine too. And I have those as well, but I figured this one with a domed lens would shine the light in a bigger arc. And that was what I was going for, to try and imitate the big bulbous one they had in there, the 8mm LED that they had. And it does. And it does exactly what it's supposed to do. And you can get a replacement 8mm LED. I just didn't want to wait, because when I wait, this just sits in a corner until it shows up, and then I have to put it back into the queue of repairs. It's better if I can try and fix them all in one straight linear line. Makes it easier for me. I don't lose pieces that way. I haven't lost any yet. So you just need 3 different color LEDs, because that's what the house had. If you want to change them because you smoked them and you want to change them to different colors, now's the time to do it. Just when you get your LEDs, read what the voltage is. So if you get a UV LED that runs at 5 volts, it's not going to run very well, since this house only runs on 3. So be very careful of what you buy if you want to change your colors. Red runs between 2 and 2.2. Orange, the one here, is rated to run 2.5, or actually it's rated about 2.3, but it's really dim. But I'd say 2.5 to 2.7. Above 2.7, you're exceeding its amperage rating. Same with that on 2.2. That white one is rated at 2.7 to 3.2. I did run that resistor for two reasons. It's a stop a spike. When you give it power, you can get a voltage spike, and it mutes the color a little bit so it's not stupid bright, because white can be really bright and overpowering, and it's a Halloween piece. You don't want it so bright it takes away from the other colors, especially since these are more the focal point and that's just an accent piece, because it provides no light around it, unlike these two lights here, which provide a light and light and light. So that's more of a accent piece. But there you go. So it's not the easiest thing to work on. If you have a solid porcelain house and you have wires broken inside, thin needle nose or fishhook remover works really good. You would hopefully have a soldering pen, so you have the longer shaft to reach inside. With a soldering gun, you don't have that if it breaks inside. Now, if you have one where you just need to replace the LEDs, then you don't have to worry about the soldering pen versus soldering gun. Just make sure temperatures aren't too high. Soldering guns tend to get really hot. Yeah, this one is glued in. Carefully wiggle it out, and then there's slack in the wire. Do not pull it all the way out, because fishing the wire back through, you're not going to have a good time. So let's try to avoid that. Same with this. This one's not as bad. Once you fish the wire through this little loop, you can make a curl of it and then fish it through the hat, and then slowly keep pushing it till it gets past all the nooks and indentations to where you can grab it with something long and thin and pull it out the bottom. That was going to be my second choice if I couldn't get a soldering pen in here to extend that wire. Luckily I could, and I didn't have to fish new wire through. So the only thing this needs before it goes back to its owner is a base, and that to be painted black so we don't have the white shining from the base of the LED. So other than that, any questions, comments, put them below. I know it's not the most exciting video. It's kind of a long video for what it is, but these are the kind of things you encounter with solid porcelain houses, which is why I said plastic and resin are so much easier to work on. They're not as fragile. They don't have the heat issue where if you get it too hot, it shatters. You can melt them, yes, but shattering them is completely different. Melting is still there, it's just distorted. Shattering, you're gonna need a lot of glue or a replacement piece. So, but there you go. There's Esmerelda's The Shoe Shop with new LEDs, new resistors, slightly larger ones, being 1/4 watt versus 1/8, and new color palette, basically. Because these LEDs being newer than this house, the hue will be slightly different. But there you go. Not too bad. You're going to have a problem with this one. You'll probably crack when you try and pull it out. Wiggle it, light heat. You might get it out without cracking it. But as you can see, there is almost no marks on it. You can see a little bit right there where it's shining through. But since I need to repaint the top, I'll paint the little line of white light too. There you go. Three LEDs, 3 resistors, fixed. All I need to do, new cover, little paint, she's done. So until the next repair, thanks for watching.